All right, in this video we're going to prove our first trig identity. So I've chosen this as an even numbered problem from your textbook. It's number 46. We're proving that tangent of alpha over secant of alpha is equal to sine of alpha. Now you'll see with the identities, the book often varies what the name of the input is. That's just because it doesn't matter. Okay, that's just the name of the angle. If this is an identity, it's true whenever both sides are defined, and it doesn't matter what we call the angle. Okay. Now, one super important rule when I'm proving identities is that I can only work with one side at a time. Now, what do I mean by that? Well, equations have two sides. I'm going to just label this LHS. That stands for the left-hand side. And then this I'll label RHS. That stands for the right-hand side. Now the idea is if I'm being asked to prove this, I don't know that it's already true. So I can't say that they're equal and work with both sides of the equation, because then I'd be assuming what I was trying to prove. What I need to do is work with just one side at a time to somehow modify the way the sides look until they look the same. Let me just show you why that's so important. Okay, if I were to start with 2 equals negative 2, that is false, right? We know that that is not true. Okay, so that's an equation that's not actually true. But if I treated it as an equation and I said, oh, well, if I have an equation, I'm allowed to do the same thing to both sides, and I were to square both sides, I would get 4 is equal to 4. Now that's something that's true. So if I start by saying that two things are equal, if two things are equal, I'm allowed to change them both as long as I change them the same way. But if I do that and I started with something that wasn't true, I could prove something that's not true. So very, very important that I'm only working with one side at a time. Okay. Now I do have two options for how I do that, and I'm going to show you one option in this video and one in the next one. Okay. The first is I can just pick a side to start with, and I'm generally going to pick the more complicated side, because I would rather take something that's complicated and make it look simpler than try to take something that already looks pretty simple and try to make it more complicated. Okay, we're sort of in the business of simplifying, so let's start with something that's more complicated. So I'm going to start with the left-hand side, and I'm going to say that's equal to tangent of alpha over secant of alpha. Then I want to think, okay, how do I deal with this? Often a useful strategy is to write everything in terms of sines and cosines, because that way I get it down to just two functions. I go from 6 things to work with to 2. Also, I can see that my goal is to get to this right-hand side, and that involves sines. It doesn't have any of these other functions. So I'm going to do that. I'm going to just rewrite this. I'm going to use my quotient identity for tangent and say that's sine alpha over cosine alpha. And I'm going to use the definition of secant, which is its reciprocal identity, that's 1 over cosine of alpha. But now I can see I have a fraction divided by a fraction, and I know that when I divide fractions, I just multiply by the reciprocal. So I can say that's sine alpha over cosine alpha times cosine of alpha over 1. And that's great. Those cosines are going to cancel. And so I get sine alpha, which is the right-hand side. So here, with this technique, I start with one side and I simplify until I arrive at the other side. Okay. That is a totally acceptable proof. But notice it was clear that I was always working with just this side. Okay. All right, back for another one in the next video, and I'll show you another option for how to work with just one side at a time.